So we really have the same learning goal today that we had yesterday, factoring special products. So today we're going to just continue on in that. We're going to use the rules we used yesterday. Here we're going to apply it to a problem where we have to use a little bit of problem solving. We have a square piece of cloth that must be cut to make a cover for a table. The area needed is this crazy polynomial 16x squared minus 24x plus 9 inches squared. The dimensions of the cloth have the form ax minus b. This would be an example of an ax minus b. 3x minus 2. A is 3, b is 2. Okay, negative 2 basically, or if we change it to add the opposite. Where a and b are whole numbers. Find an expression, so basically another polynomial, for the perimeter of the square piece of cloth that has been cut. And then step number 2, find the perimeter when x equals 11 inches. What's perimeter? What's that mean? Add up all this up. Yeah, distance around it. You start measuring all the way around it, from one corner back to that same corner, you should have the perimeter of that figure. What's area then? Length times width. If we're talking a rectangle, if we're talking a different shape like a triangle, trapezoid, they each have their own area formulas. So perimeter is what dimension? What dimension is perimeter? 1, 2, 3. No, it's not 4. It seems like it should be because there's 4 sides maybe to a square, but it isn't 4-dimensional. No, it's not 3-dimensional either. 2. It's not 2-dimensional either. Well, guess what? Then that leaves 1-dimensional, doesn't it? 1-dimensional. In other words, we only measure the length. If we could take that figure and cut it apart and spread it out, the distance around it, we're only measuring length. It's 1-dimensional. What's area then? 2-dimensional, because we multiply one dimension times another dimension, so we have 2-dimensional when we're working with area. So we got 2 different things going on here. We have a 2-dimensional amount. They want us to find a 1-dimensional amount. So how are we going to go about this? So let's deal with first number 1. Let's draw this cloth. It's a square, so try to make it, look as close to a square as you can. We know its area, right? Its area is 16x squared minus 24x plus 9. Do we know its dimensions? Do we know its length? Do we know its width? No. What do we know about a square, though, other than right now we know this square has this area? What do we know about a square no matter what square you're talking about? It has 4 sides. It has what? It has the 4 equal sides then. Every side is the same length. Okay, so that's good to know. Because if every side is the same length, that probably helps me decide something about, well, how can I determine its perimeter then? How can I determine its area? So right now we don't know what those dimensions are though. So anybody know how we could shortcut finding the area of a square, Benton?
If every side is equal, that means that the area is a square number.
That means it's the side squared, isn't it? Area equals side length. I'm just going to put that in parentheses because it's 2 words. Side length squared. In other words, once you find out what the dimension of that square is, you can just square it because the length is the same as the width. Take them times each other. Okay, so if that's all we have to do, then we should be able to do, the area is this, we should be able to say then, I can find the side length and square it. What do you suppose suppose we need to do with that area then? Square root it. Okay, do we know how to square root a trinomial? We do. Okay, how are we going to do it? Help me out. How are we going to square root the trinomial? I like the idea, I really do, but I'm just kind of wondering how we're going to do that. Can we take the square root of 16x squared and then say, okay, well, and then take the square root of negative 24x, and then take the square root of 9 and just mash them all together and say, here's the square root of the trinomial? Probably not. What did you learn yesterday? Is it possible this is a perfect square trinomial? No. Okay, what part? What makes it not a perfect square trinomial? Let's explore that then. Okay, let's write this down. 16x squared minus 24x. Maybe yesterday's notes would be helpful. To meet the conditions of being a perfect square trinomial, did the middle term have to be a perfect square? No. What did? The first and the last. Okay, so basically we need to determine, can we take the square root of 16x squared? Can we? Yeah? Okay, what is it? 4x. Can we take the square root of the last term? Why can we? What haven't we checked yet? Do we have a positive last term? Yeah. Have you ever tried to take the square root of a negative number? Doesn't work, does it? Can you find something that times itself would give you a negative? If you do, if you discover a number times itself that gives you a negative, could you let me know? I want to make that math book with you that shows that we've discovered something new. Because I don't know how you're going to multiply something times itself and get a negative, because the only way to get a negative is a positive times a negative, isn't it? So this is 3, right? So far it's passing all the tests. The first term is a perfect square. The last term is a perfect square. The last term was positive, so that we could take its square root. And then we have to see if it meets the middle term thing. 2 times those square roots, the product of those square roots. What is that? What's 2 times 4? 8. What's 8 times 3? 24. Huh. But we need a negative 24. You can have a negative 3 square root also, can't you? Yeah. Okay, so we have a negative 24x. It is a perfect square trinomial. Oh, isn't that convenient? Because what's its factored name now? 4x plus 3? 4x minus 3? Is that its factored name? Really? Huh. I could swear yesterday, somebody must have turned the earth around, because I could swear yesterday we said that when you have the difference of 2 squares, it will be one addition, the other subtraction. But I'm pretty sure that when we had a trinomial, it was, oh, the middle term gets to rule the operations in the factor. They should both be subtraction. Yeah. Darn, we forgot that overnight. Isn't that something? Also known as 4x minus 3 squared, right? Oh, I wonder if we could take the square root of that. Because remember, you wanted to take the square root of this trinomial. Well, we just renamed it. So can we take the square root of that now? You can't? Really? Huh. So you're telling me I can't do this? You're telling me? Really? Huh. So you can't give me anything that times itself would get you 4x minus 3 squared. I challenge that. I I say 4x minus 3 is the square root of this.
Oh, it's already squared.
Oh.
Yeah.
What times itself, when you're looking for the square root, you're looking for what times itself, what's already being multiplied times itself. So basically, people, if this is the area that we have right here, if this is the area, when we renamed it right here, here's its length, here's its width. Remember, they have the same length and they have the same width within a square. Each side is the same. So we now know the dimension that we need for this square. It's 4x minus 3. It's 4x minus 3. 4x minus 3 times 4x minus 3. Oh, that gives you the area. Oh, wow. You know, just talking about it with a different name is all. And with those darn variables and no numbers. Makes it so hard, huh? Okay, what was it we were supposed to find in number 1? Oh, find an expression for the perimeter of the square piece of the cloth. Do we have the perimeter yet? No. Well, darn, what was all that work for then? For nothing? Seriously, we just wasted all that time for nothing?
So that you would know what the side lengths are.
Oh yeah, we need to know what the side lengths are, don't we? Yeah, because perimeter is equal to, in a square, perimeter of a square, we better specify that. Perimeter of a square is equal to 4 side lengths. Well, jeepers, we know the side length now. So we are going to say, oh, well then, we just have to take 4 times our side length, 4x minus 3. And we will have an expression, also known as a polynomial perimeter. What is it? 16x minus 12 is our perimeter. See, we were a lot smarter than we realized.
Wait,
Huh?
where did the 4 come from?
Because there's
4 sides.
4 equal sides in a square. Yeah. Okay, now we've done the hardest work that we have to do. Number 2 is going to be a cakewalk. Find perimeter when x equals 11. Isn't that what it said? Mm-hmm. 16 times 11 minus 12. Don't you dare use your calculators. Don't! 16 times 11. 16 times 10 is?
160.
We need another 16.
476.
176. 176 take away 12?
160.
4. 164. See how good we are? We didn't get our calculators. 164. Oh,
Inches.
oh, I was going to just ask that. What was the area labeled in? Inches squared. So that means inches got taken times inches. So these are inches. Okay. And by the way, back up here, we could also put that in parentheses and say inches. And back up here, we could put this in parentheses and say inches. Yeah. All over the place. We got inches. Okay, questions on this at all? You're going to be doing it in your homework. No pretending. Okay, let's go to the back then. Okay, we're going to start kind of doing what we're going to be doing tomorrow also because we need to get, like, not all overwhelmed with it in one day. And of course, I'm expecting you to carry over something in your brain for 24 hours, just like you did for today. Sometimes you can use some other method of factoring first, and one of the factors is a special product, and then you'll factor that also. Oh, that happened in that number 50. Okay, first thing I want you to look at is our 6x squared minus 6y squared. First of all, it has subtraction and it's a binomial, so it is possible. Are you all ready, Tim? Okay. possible then that it could be a what? If it's a binomial subtraction, we have to check it out to see if it is a difference
Of
of
squares.
squares.
Yeah.
Is it? What's the problem?
Probably.
Pardon? What's the problem?
6x, 2.
6 is not a
Square number.
perfect square. It's not a square number. You're right. So here's what we're going to do. We're going to GCF it first. Because we know how to do that too. Well, at least we hope we still remember how. What's the GCF of each of those terms?
It would be like
3 and 2.
2 and 3. So if we do prime factorization, yeah, but do we need to? What can be divided? What's the largest thing that can be divided out of both of them? 6.
Yeah.
Can we take any variable parts out?
No.
No, one has x's, the other has y's. So what's the other factor then? 6 is a factor and
1.
divide it out now.
3, 2. 1 and 6.
6x squared divided by 6 is x squared. Really? 6y squared divided by 6 is y squared. Oh. You'd think this was 2 years ago. Like, really? 2 weeks ago we were doing this. Okay. When we were only learning at that time how to factor by the GCF method, that's all we knew how to do. We would have stopped right here. But now, we have more tools, supposedly up here, that we can use. So we're going to look at that and say, okay, can that x squared minus y squared now be factored? So it is a binomial. It has subtraction. So we need to check it out and see if it is a difference of squares. How do you feel? Do you think x squared minus y squared is a difference of squares? Let's try. Okay, this is coming down. Remember how we didn't ever want to forget about something? So like that GCF of 6 is coming down. Let's try this. Can we take the square root of x squared? What is it? X. Can we take the square root of y squared? What is it? Y. Oh, well, then they're both perfect squares. There's subtraction. This is the difference of squares. What would its factored name be? Both would start with x. Both would end with y. Now what? Plus and minus. So our final factor name is so just because 6 wasn't a perfect square, we don't get to say this is a not, this is a no, I can't do anything. Oh yeah, we can. We just proved we can.
Let's try though.
Let's try another one.
How about
Is 12 a perfect square?
Yeah, no.
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 Well then let's get it out of there. Okay? And let's not make this so, hard this time. What's the other factor then? X to the 4th? Minus y to the 4th. Okay, 12, you're 12, you're going to stay 12 for now. We're going to arrow you down. Now we're going to decide, can that x to the 4th minus y to the 4th be factored? There's subtraction, it's a binomial. I'm feeling like I better give it a try. Square root of x to the 4th. X squared. So far, so good. Square root of y to the 4th. Y squared. This can be factored then, can it? Its factors are x squared. They both start with x squared. They both both end with y squared plus and minus. Are we done? Why not? Oh, which one? The one with subtraction. This is coming down. It cannot be factored again because why? It has, this one cannot be factored again because it has addition. So we know we're done with that one. We cannot factor the sum of squares. So now we're going to try this one. Can we take the square root of x squared?
Yeah.
What is it?
X.
X. Can we take the square root of y squared? What is it?
Y.
Y. Oh, well then that makes this a difference of squares. Its factored name is,
X squared plus Y squared.
no, x is the square root of the first term becomes the square root, or becomes the first term of the binomials. The y's and the binomials. One has addition, the other has subtraction. This one's got addition. I already know I'm done with that one, right? Don't have anything to do with addition of binomials. How about this one? Are we done with that one? Can you take the square root of x? No. So we finally have the name of this one. Four factors for this one. It has a GCF, then it had the factor x squared plus y squared that could not be factored again, and then after enough effort, we came up with two more binomials.